So let me go a little slower. So again, here, okay, so here basically what we have is we have another example, okay? Now, what we want to do is we want to be able to take out, withdraw, that is, $1,500 each month. You know, that's what we want to do for 25 years. You know, so we're retiring, okay? That's what's happening. In other words, you know, we worked hard all our lives, well, most of it, I should say. And now for the next 25 years, okay, we want to be able to do this. Take out $1,500 each year, okay? Let's assume that the account is earning, our retirement account is earning 6% each year. Let me just see, can you, everyone see? Yeah, okay. So let's just, oh, sorry, wrong button. Here, this one. Okay, my mistake. So we're gonna assume the retirement account is earning 6% interest. So our APR is 0.06, 6%, excuse me, 6%. We want to know, how much do we need to have in our account when we retire? So we want to know, so I guess we're planning ahead. We haven't retired yet, but we want to know, how much should we have in our retirement account in order to accomplish this? You know, being able to withdraw $1,500 a month for 25 years. Okay? Now, okay, so notice that we're going to do multiple withdrawals, right? I mean, that's implied. We're going to withdraw an amount each month for 25 years. So since we're making many withdrawals, that tells us we want to use a payout annuity, that formula. In other words, we want to use this formula. That's what we want to use. Okay. Well, we have to figure out what our parameters are. You know, we have a word problem here, right? Somehow we want to figure out what the parameters are. Well, again, we want to withdraw $1,500 per month. So that's our PMT. Our PMT is what we want, is our monthly withdrawal or monthly payment. P0 is how much is in the account, you know, when this all begins. So when this whole situation occurs, right, we're withdrawing each month for 25 years. P0, okay, is how much we start with in the account when we do all this. You know, when we're withdrawing, when we retired for 25 years. But that's what we want to know, right? We want to know how much is in the retirement account, how much we need to have in there. So that's what we want to know. What's our R? 0.06, right? That's our APR as a decimal. And, well, since we're withdrawing each month, hypothetically, no, we're taking out money each month. By assumption, our compounding frequency is equal to how often we're taking money out or making deposits. So we have 12 here. Since we're making monthly withdrawals. 25 right? 25 years. So altogether, our formula then becomes this. That's what our formula becomes. Okay, that's good. So now we have to do some calculations. Okay, let's do it. So we plugged it in, PMT, 1500. Okay, R is 0.06. N is 12. Negative NT, negative 12 times 25. R over N is so. Okay. Remember, you don't put a negative number into the formula. For that TVM thing, that TVM formula, that TVM solver, that's it. That you would, but not for this. Okay. So this is what we have to calculate. Again, what I would do, okay, is handle the top and bottom separately. So 0.06 divided by 12, you could do that in a calculator, right? Then you would handle the top after that. You know, once you get this quotient, what I would do is make sure you have as many decimal places as you can. So if you want your answer to have 2 decimal places, right? I mean, that's kind of obvious because it's money. So I would make sure you have 4 decimal places at least in the numbers, maybe more. You know, the more you have, the more accurate. So do the bottom first. Then do the top. Although the bottom actually turns out to be exactly 0.005. So, well, yeah, that's okay. Right? So we have 1 plus this. And the exponent, as you can see, is negative 300. Negative 300. So we have 1. So we do this raised to the negative 300, right? 1 minus this. Right? 1.005 to the negative 300. If you do that in your calculator, you could do it now if you want. You should get this number. Then you have 1 minus that. Multiply by 1500, divide. All together, you should get this. $232,810.30. Okay? So you know what? I have an idea. Let me just wait. Let me leave this up here. Why don't I just wait about like 3 minutes, I guess. I want everyone to put this in their calculator and see that they get the same answer. And I want to make sure everyone does that. So let me just set the timer. Let me stop the recording. So she has to have in her account $232,810.30. Well, that's what she has to have in order to be able to take a monthly withdrawal of $1,500 for 25 years. Now, that's the formula. Let's use the TVM solver. So this is the same problem. The only difference now, though, is we're going to use that TVM solver. I know it's annoying because it doesn't use the same parameters, not entirely the same ones as the formula. Now, PV, right? You know, that's how much we want in the account now in order to be able to withdraw $1,500 each month for 25 years. So that's why this is our unknown. This is how much we want to be in the account when this begins. Our PMT, right? That's our monthly withdrawal. That's this. Also, that's going to be positive because we're getting that money. 6, right? That's our APR, but we leave it, we don't convert it to a decimal. N is 12 times 25, which is 300. FV, right? That's 0 because the account will have in the end 0. You know, in theory, that's what should happen after 25 years. And since we're making monthly withdrawals, we have this, right? Compounding periods per year, that's always equal to how many withdrawals we're making. So in this case, that's 12. These two are equal. So now, let's check out the TVM solver. There we go. Let me clear this. So even though I said it in words, let me put the numbers in. So N, capital N, remember that's 12 times 25, which is 300. We said I was 6%. PV is what we want, so let's leave that alone. The PMT, that's $1,500 per month. FV we said is 0. P/Y is 12, and so is this. So we solve now for PV. Click the button, and we get this. Negative $232,810.30. Make sure you click in the cell because I couldn't see the decimal at first. But we get the same answer. That is, we get the same answer. It's negative because that money is in the account to begin with. Okay. So that's it for today.